1,500 years since the time of the ancient Greeks, there was a view that the Earth was the center of the universe, the sun and the planets and everything were rotating around it, that everything below the moon were the basic elements of earth, air, fire, and water, and that all of the planets and stars were embedded in what are called celestial spheres. It was thought that these spheres were being rotated by the hand of God at the outside in heaven. So when people talk about looking up at heaven, that was quite literal. And it wasn't until about 500 years ago when Nicholas Copernicus came along and proposed that Earth is not the center, that in fact the sun seemed to be the center, and that the Earth was rotating around that. But even here you can see in this little picture of the moon and the Earth that it was still thought that this was the elemental region and that everywhere else were these crystalline spheres. It was like these eternal, unchanging spheres. And it wasn't until the past few hundred years that our view of all of that is completely shattered, that we now don't talk about celestial spheres anymore. Now, the elements have been expanded into the periodic table, and we see the periodic table is existing everywhere, that elements are all over the place. This is called the Mediocrity Principle. And it implies that the Earth is mediocre, it's just like everywhere else. And really, a lot of the way, I mean, at least the way that I was taught, astronomy and a lot of sciences, is this idea that Earth isn't really anything special. Well, turns out that it's not quite so easy, right? That as we study space, once upon a time we thought we would find little green men on the moon, we'd go to Mars and we'd find rivers and planets that would have all kinds of life forms. But it turns out that our planet is in a very interesting place within our own solar system. It's just the right distance from our sun so that it can retain liquid water on its surface. This is called the habitable zone, sometimes called the Goldilocks Zone. It's not too hot, it's not too cold. And if you're closer into the sun, it's too hot and water evaporates. If you're further out, water freezes. Look at our orbit, right? So it's thought that we are in this really ideal place, and we orbit the sun in this elliptical pattern so that we have these seasons, and these seasons have enabled, over the course of billions of years, and these very stable conditions for complex life to emerge on our planet. And as we look out at all these other planets, and as we listen for radio signals from other places, we're not finding anything. And so it turns out that the Earth, perhaps isn't quite as mediocre as we've been taught to believe, that the Earth might actually be quite an extraordinary place that's worth watching after. Because, we all grew up with a lot of science fiction and these kind of plans of conquering space. And it wasn't until pretty recently that, actually in the past few months, that astronomers have found habitable zones around other stars that have planets in them, right? And they got really excited. It's actually thought now that some of the earliest cave paintings we found, this is the cave of Lascaux in France. We'll zoom around here. It's actually thought that these figures, this birdman and this bison and this little bird, are actually the summer triangle of stars in the night sky. And that the birdman is flying along the Milky Way, which we can't see very well right now, but I can turn on some other frequency ranges so that we can see the band of the Milky Way. That's looking at atomic hydrogen. We can look at carbon monoxide. So we can use these telescopes and instruments to help us see things better and to understand the chemical makeup of other parts of space. But it's all relational. Keep in mind that everything is relational. It's what the theory of relativity is all about. That you can't talk about anything without it being in relationship to something else. Now, this is something that a number of indigenous traditions have been talking about for a very long time. I think it would do us well as a modern, scientific culture to realize we can't have a God's eye view. There is no view outside of consciousness. That our consciousness is perceiving all of this. We'll get to that in a minute, but it's really important to recognize how we are actually embedded within this entire system. Now, all of these blue crosshairs I just turned on are other solar systems that have been discovered in the past 15 years. Before 15 years ago, we'd never found any. Now there have been hundreds and hundreds and hundreds found. And we're actually sending out radio signals, and have been for about 80 years, that are now washing over some of these other solar systems, right? So that's about how far the signals have gone out, traveling at the speed of light beyond Earth. That's about an 80 light year radius sphere. And that's what SETI is doing. If you've ever heard of the search for extraterrestrial intelligence, they're looking for that, listening for that from other advanced civilizations, supposedly advanced civilizations. And nothing so far, nothing at all. And the first habitable zone was just found around another star that had a planet in it a few months ago. And astronomers were really giddy. I was watching the NBC News, and Brian Williams was like, wow, at least if we screw this planet up, we have somewhere else to go. I was like, okay. Yeah, thanks, Brian. So fair enough. Why don't we run the numbers and figure out how far away that little planet is? It turns out it's 20 light years away, which would literally take us millions of years to get there with our current propulsion technology, right? So just, if you don't walk away with anything else tonight, just remember, like, us going to another planet to live is complete bullshit. Don't let anybody tell you that. Don't read all the science fiction you want, but the only way we're gonna go to other planets is in our minds. And this is how we're gonna do it, and this is cool, but this planet is the only one we've got, and we gotta get our shit together, because we have to take care of this one. So that little model that you're taught in elementary school of the solar system is a complete lie. That we're not just going around a static sun. Our sun is actually traveling at about 500,000 miles an hour around this galaxy. So that means that the orbits of planets around the sun are actually these helical patterns as we fly through space. So we're kind of like spiraling along. So we're going at 60,000 miles an hour around the sun, but the sun's traveling at 500,000 miles around the galaxy, which means that when you got up this morning and you go home tonight, you're millions of miles somewhere else, right? You're all verbs, I'm telling you. You don't exist except in your own mind, and it's constantly happening, and we're making sense of all of this. So be grateful for it, that we're able to be here and actually have fun with this. And it turns out that all the gravity from these galaxies are attracting each other. So all these galaxies are doing this kind of beautiful dance around each other. You can see these gravitational contours, these clusters. We've got a local group of galaxies, a little over 30, but we're seeing all of these other galactic families dancing around each other. Now the funny thing about this is that, through physics we correlate mass with gravity, but it turns out in the past few decades that astronomers have realized there's way, way, way too much gravity to be accounted for by the amount of mass we see. So they've had to invent an entirely new form of invisible matter, right? Dark matter, they call it. That they have no idea what it is. They've never been able to detect it, but we visualized it here for the first time. This is like how much matter should be there between us and Andromeda, our closest galactic neighbor, in order to account for the amount of gravity we see, right? So either all of our equations about gravity and mass are wrong, or there's some entirely new kind of matter we can't see, either of which are equally hilarious, Because the idea that we're gonna figure all of this out and we're gonna come up with these theories of everything, I find to be incredibly hubristic. And that the further out we look, we find out a lot of amazing things, but the mystery also deepens at the same time. It's quite a paradox. So the first time I ever saw this, I was totally baffled. I was like, what? The universe is a giant psychedelic butterfly? What? But what's the thing at the middle? What? Why is that black? What? So in my layman's terms, I'll try to explain to you what this is really quick, right? So there are these black areas at the top of the bottom. Those are our blind spots. Astronomers call them the zones of avoidance. It's basically stuff we can't see because our galaxy has so much radiation from the other stars, it's difficult for us to see on the other side. Right? So it's kind of nice because it's like zones of avoidance. It's sort of a nice metaphor for how we all walk through life, and we've got these shadow areas that we don't want to look at, but it's sort of baked into the nature of perception. So don't, just realize you are just the universe doing its thing. And then there are these little slices. Well, those are actually holes in the data set where telescopes look out and they collect images on these very thin slices and they map them. And so these are all just surveys that are being conducted, right? So this is basically a huge incomplete data set. Now the really funny thing about it is that we're at the center, right? We're at the middle of this. And it's because we're like taking this giant panoramic photograph. If any of you ever gone out and like taken pictures all around you and stitched them together, like for a QuickTime VR or something, you're always at the middle of that. And astronomers call this our observational center. And it's just the way it works out as we're trying to take pictures of these large scales, because there's no way we can take a picture from somewhere else. So like, this is our observational center, but it's also our ecological center, right? It's the only place that we've found. I mean, we are Earthlings. We need to come to grips with that. We think that we're like not of this planet, but the more we look out, the more we realize, like, this is actually our home. What they're finding out is astronauts that are spending 6 months on the space station, after 6 months, these like really buff, healthy 40-year-olds have atrophied to the bodies of 80-year-olds, right? Because we are so adjusted to the gravity, to the atmosphere, to everything we take for granted on this planet, that it's critically important that we realize, like, we have to take care of this home if we ever hope to go exploring any of these other places. What's really crazy about this is that, you know, none of it is there anymore. We're not looking at anything as it is right now. Everything that we see it because it's emitting or reflecting light. And as we look out at these deep galaxy surveys, light that left this galaxy didn't take nearly as long as the light that left that galaxy or that galaxy or that galaxy, because light has a speed limit, right? Even though it goes at 186,000 miles per second, really, really fast, it takes that light millions, tens of millions, hundreds of millions, billions of years to get to us. So as we look out into space and we're collecting photons, we're not actually looking out into space. We're looking at photons that are hitting our telescopes or our eyeballs right now, right? And so we're basically looking at memories of all of these things that were there. So we're looking not only out into space, but also back into time. This entire thing is like a huge memory theater that's enabling us to reconstruct the course of cosmic evolution. The further out we look, the younger and younger and younger those galaxies are. The things that the person sitting next to you is the most like advanced thing in the universe to you, right? It's like the most recent thing. And the further back we look and the further out we look, the younger things get. So this whole thing, it's not really right to call it a large-scale structure of the universe. It's a large-scale structure of our perceptions of the universe. It's what we are able to construct right now. Which means that if we look out far enough, we should be able to see what?
God. The creation of the universe.
The beginning of time. How's that? God, beginning of time, creation, whatever. So, like, and that's precisely what is thought to have been discovered in the 1960s when some astronomers found radiation emanating from everywhere in the sky. It was this microwave radiation that we now call the cosmic microwave background. And it's thought that this is light emanating from very, very shortly, like just within a few 100,000 years after the Big Bang, which was a derogatory term for whatever this crazy event was, that is still a theory. I mean, it's like that's the standard model of how all of this works. And it's thought that this radiation, like those red areas in the background, were the places that eventually became quasars and galaxies and stars and planets and everything else. And as it was dissipating and cooling down, it eventually became the material universe that we know. So this is essentially our horizon. We can't see anything beyond this because light hasn't had enough time to travel in the 13.7 billion years of the universe to get to us from anywhere beyond that. But because this is a funny little game and a simulation and a map, we can actually move out beyond our own horizon, right? This is the extent of everything we've been able to measure on a cosmic scale. Ironically, Earth is at the center and we're surrounded by a celestial sphere, right? So like we just got medieval on our ass. I mean, like I'm amazed this isn't like all over the news or anything, and I still have to this day have ever heard a scientist actually like go into this, amazingly. But I think it's really special because in order to understand what this means, to understand that we're not just looking at some objective model of the universe. We're looking at this thing that's been created through our own self-consciousness, through our own perspective, that as we look out into the cosmos, we're actually bringing it into being. We're like collapsing the particular point of time that we can see those galaxies. And it's all centered on where we are. But if we were somewhere else, we would seem to be centered here, with a horizon line there, or here, it would be over here. So in a very real sense, the center of the universe is wherever there's a consciousness to perceive it, right? And so like whenever you're, fighting with your kids or your husband or your brother and sister, and you're like arguing about, who's the center of the universe, like you're both right, You're like, rest assured, it just works out like that. So because this is all our imaginations anyway, we're just going to imagine these photons leaving 13.7 billion years ago, traveling through space and time, the creation of all of these quasars and galaxies and stars. And eventually some of those photons landed in one particular galaxy that had given birth to one star that had a habitable planet that was just the right conditions, where everything was just groovy for billions of years. And eventually it gave rise to one species that started scratching its head and saying, where the hell are we? It started launching satellites and telescopes and collecting all kinds of data, and eventually figured out this thing called the cosmic microwave background that was put into a computer database and reprojected on this screen, bounced off the screen, landed in your eyeballs. And in a very real sense, by you processing everything that we just saw, you just became the universe becoming a little bit more aware of itself after 13.7 billion years of cosmic evolution. Now give yourself a hand. All right.